Welcome to this class from this lesson. Hi everyone, welcome to this lesson. So in this lesson today, we'll be looking at chapter 3 of my book, Multi-Agent Orchestration Pattern for Enterprise Scale System. And I will be looking at the content of chapter 3, one after the other. So this would just be like a guide. If you want the full content, please check the link below and purchase the book. It's available on seller for Nigerians and Africa. It's available on Amazon for UK, US, and the whole world. So do well to buy the book and check the content. It will be useful for you as an AI engineer, agentic AI engineer, even for data engineer and machine learning engineer, system architect, and data and AI solution architect and technical managers. It is very, very, very important that you have this book if you want to work in an enterprise system and as an agentic AI engineer or AI engineer, or even for data engineer. It is very, very fantastic. I put the book together through series of research in software engineering, data engineering, and system design. So I put a lot of knowledge together there, from site reliability engineering, from artificial intelligence, from data engineering design pattern, and agentic AI design pattern, all put together in one to show you how you can design orchestration pattern for multi-agent system in an enterprise scale setting. So this is chapter 3, and then we'll be looking at it together briefly. And please remember to subscribe and like this video so that you can get more content from us. Thank you. So multi-agent orchestration pattern, design pattern for the orchestration layer. So this is the core topic of the book, and then we'll do well to break it down so you understand. So study guide, including key explanations and all code listing section by section. So the code listing section by section is in the textbook. It's also in the code repository, which I'll put the link below, and the link is also in the textbooks. And also check our websites for research papers and insight and white paper, and follow us for more insight on agentic design pattern, data engineering, system architect, solution architect, cloud computing, and cloud solutions in general. So, all right, we have the first chapter here. So, orchestration, as we know, comes from the word orchestra, which is used in music. Okay, so in biology, we're taught about nervous system there in secondary school. So where we have neurons, our whole system communicates through neurons that are connected together in layers using dendrite and everything. So, and then the brain, everything is connected to the brain. Whenever this neuron receives message, it is passed to the brain decide and then send information to the neurons. That is how multi-agent system also flows. So the word orchestration comes from the conductor of an orchestra. So if you have a music group, you notice that there is always a coordinator that will stand in the front and coordinate the music, the flow of the music, the flow of the tone, the flow of every instrument being played in the setting. So that's an orchestra or coordinator, which allow the music to flow seamlessly without any confusion or interruption. So someone who does not play an instrument but whose job is to ensure that 80 musicians produce something coherent rather than cacophony. So that is an orchestra. So this term is also used in agentic system design, where you have a coordinator agent acting as an orchestrator and will coordinate all the activity of the agent. That is, it acts as the brain of all the other agents in the system. So this analogy breaks down in software because Agents encounter unexpected situations, fail in unpredictable ways, and need to make autonomous decisions. So the real question in orchestration design is, how do we structure coordination so that the right things happen reliably, even when individual parts behave unexpectedly? So that is the problem we are trying to solve in chapter 3, and it is of course solved. So this chapter walked through 8 distinct orchestration patterns, from the most centralized to the most distributed or hybrid. So orchestrator decide what gets done in a JFT system, and in what order. It determines by whom what gets done, in what order, by whom, and what happens when things fail in the system. That is the work of an orchestrator. So now let's look at the 8 orchestration design pattern that we explain in the book with quotes or guide. So the first one is centralized orchestration pattern. So this is used when workflow matters, okay, when compliance is important, when audit trail is required, when approval gates are needed in the system, and when global consistency matters. So it allows complete feasibility and governance of the system. So when you need structured workflow in an enterprise setting, then you use centralized orchestration patterns. So there is one orchestrator that knows about all agents and decide what happens. It knows all the agents, even though there are 50 of them, it knows all of them by their identity, and determines what happened to or who to solve a particular problem. It assigns the right task to the right agent and coordinate the agents totally. So here, agents don't have the capability of talking to each other. They don't communicate with each other. They communicate through the orchestrator. They send message to the orchestrator receives the message, process it, and send it to the next agent who needs to process the information. So there is no agent to agent communication here. Every communication flows through the orchestrator. So we have centralized orchestration architecture are designed here. All agent interactions are initiated, okay, and tracked by the orchestrator. So workflow state, the orchestrator maintains the state of every workflow instance, just as I have explained. No agent call or another, no agent to agent communication. Feasibility, so every workflow step passes through the orchestrator. No agent work in isolation. No agent work with each other. They work with the orchestrator. Every workflow passes through the orchestrator from external to internal, okay, to get done, providing complete feasibility in the system. Auditability, this is required for enterprise use case, particularly because you must build a system that is auditable and governed, and it is compliant with the policy of the enterprise. So these are, we have example here such as contract review or procurement request. Everything must be auditable. Then we have workflow status. So the status that have implemented in this design pattern are pending. You can have a task that is pending. You can have a task that is in progress. You can have a task that is awaiting approval. You can have a task that is completed, and you can have a task that failed, or a task that is escalated back to the orchestrator or to human in the loop. So this is how centralized orchestration pattern works. It acts as the central coordinator and does not allow agent to agent communication. So let's look at some of the temporal for durable centralized orchestration. How do you design durable centralized orchestration? How do you design a centralized orchestrator that is not weakened or that can withstand failure at any time? So persistent execution history to enable workflow to resume after complete infrastructure failure. So the first one is a durable workflows. So make sure all the workflows are durable. So temporal persists every step of the workflows, execution history, ensuring state is not lost if the orchestrator restarts. So make sure you implement temporal workflow, temporal system design when you are designing a centralized orchestration. We also have resiliency. If a worker crashes, temporal replace history and resume at the next step without re-executing external calls. So it also enable resiliency. So that when, in centralized orchestration, normally when the system fails, everything fails. When the orchestrator layer fails, everything fails because the agent cannot communicate with each other. So the whole system is shut down. So temporal design pattern enable resiliency in the system. Okay. So by replaying history and resuming at the next step without re-executing external calls. Then we have time horizon. So this is effective for workflow that take days, such as waiting for CFO in Singapore to approve a contract submitted in Berlin. So it also take time into consideration. So for example, if you are sending, if you are working with an agent that is hosted in, let's say, you're in Nigeria, and you have the orchestrator in Nigeria, and the orchestrator required, someone, a human in the loop that is in London to approve a task. It will take the timing into consideration and also design for that. Then we have trade-offs. Centralized orchestration is a single point of failure. Remember, if it fails, the whole system fails. So durable engines like temporal are required to mitigate such rates. So even when there is a system in orchestration and you want the workflow to continue, you have to, design durable engine using temporal design, which can stop such problem. Then for scalability, temporal design also allows scalability in centralized orchestration, the design pattern for multi-agent system, because this pattern should be able to partition by domain. This enable you to partition orchestrator or agent by domains. For example, you have orchestrator layer for every procurement agent, you have orchestrator layer for every legal agent, you have orchestrator layer for every supply chain agent, and you also have some orchestration layer for every IT agent. So this enable you to avoid single orchestrator bottleneck in design. All right, so I believe we are following. These are just the summary of the content. We have the book. Please get the book for full content and code guide. Then section 2, this is section 3.2 in the chapter 3 of multi-agent system design. We have decentralized and distributed pattern. So of course, decentralized, if you're a blockchain design, you will have heard of us decentralized or DApp, which is used for blockchain design. It is also used in supply chain programming, used in blockchain programming and supply chain programming. It's also applicable when you are building agentic workflow for blockchain applications, or when you are building agentic workflow for supply chain application. So this here, agents discover each other. Agent can talk to each other. Agent can negotiate with each other and collaborate. Agent can adapt to failure without a central authority. So there is no central boss coordinating the activity here. Every agent is a boss on their own. So this is decentralized and distributed. It's follow the decentralized pattern of design in supply chain and blockchain, and also distributed design pattern of cloud native application design. So how does this workflow coordinate? Look at how they coordinate. We have coordination. So they allow peer-to-peer communication. Agents communicate directly with discovered peers. They share state, they share information, they share message, and negotiate tasks and build together. Then discovery. Agents can discover each other capability through capability registry, distributed registry where agent advertise capabilities and load. Discovery occurs at runtime. So agents identify their capability. Agent identify the capability of each other and know which agent can solve which problem, and also discover each other at runtime. Then resiliency, particularly in supply chain, effective for disruption as fast reaction relies on local knowledge. No central coordinator is needed here. An agent could anticipate and discover one another. Using supply chain, yeah, I've built like up to 5 blockchain applications, and these are the pattern I use where agents discover each other, negotiate, and send money to each other, and it is traceable on the blockchain application. Optimization, list loaded. So agent query registry for the entity with the needed capability at the most headroom. So they also query each other for the entity that is needed for particular capability so that an information or a task is not sent to the wrong agent. Then we have efficiency. Decentralization solves the bottleneck and single point of failure problem that is inherited from centralized model. So this is very, very efficient, but it can result into a problem if it is not well programmed, and it can be expensive if you don't plan the design very well. So it is a decentralized orchestration pattern is good when central orchestrator becomes a bottleneck. When central orchestrator causes problem and causes failure in the entire system, then you have to use decentralized orchestrator. Agents need fast local decision. Use decentralized orchestrator when agents need fast local decision, when they need, when system must partially fail, and be when system coordination should happen dynamically. When you have dynamic workflow in the system, you should use decentralized and distributed orchestration pattern. Now let's look at what we call hierarchical. From the name hierarchical, that is step by step from higher to the lowest. Just like you have in enterprise, you have the CEO, you have the CTO, you have the CFO, you have the managing directors, you have the directors, you have the general managers, you have the managers, and then you have the workers. So here you can also design orchestration layer of an agentic system design to be hierarchical in nature. So this allow matching coordination structure to the organization structure, and it as it operates within real life organization. So this mirror enterprise structure, okay, you have supervisor agent that will supervise all the workflow. You have departmental coordinator agent that will coordinate each department. You have worker agent that will receive work and perform task. And then this allow, the system to be governed, to be responsible, reliable, and separated work concern, separation of concern in design. So here you have audit trails, which ensure enterprise governance. You have parallel sequence, which ensure that workflow and all agents handle work based on dependencies. We have information boundaries, which is domain specific for internal feasibility. We have worker agent, which execute specific assigned tasks as they are designed. We have coordinator agent, which manages agents within one domain. And we have top level supervisor, which handles strategy and work synthesis. So you can see the hierarchy. So I have designed one like that, like 20 of them for my company, but I have not deployed, where I have CEO, CFO, CTO, I have the general manager, I have the manager, I have the marketers, I have the analytic, and I have the analyst agent, I have the data engineer agent. I have all the agents combined together, deploy into the workflow. So you can build something like that if you have a website and let this agent work for you. Okay. So let's move to section 4, section 3.4, where we have democratic and peer-to-peer. So from the word democratic or democracy, which is defined as government of the people, by the people and for the people. So the agent, decision emerges from agent consensus via voting or negotiation. So just as you vote in democracies for whoever candidate that you want in the position of leadership, then agent also votes here and negotiate, you know, for workflows or for a particular task before it gets assigned to them. So democratic and peer-to-peer patterns is voting-based consensus, operate to voting-based consensus. So multiple agents analyze the same problem. Majority or weighted answer wins. So the person that carried the majority vote wins and is assigned the problem and is solved the problem. Okay, we also have weighted agreement. Agent assign weights. They assign weights to the problem, and then the senior agent maybe carried the weight of 2.0 to reflect trust. Then we have redundancy, natural protection against outlier result caused by model or context issue. So there is redundancy here. You have replication across. So task can be redundant here because if no agent wins, then the task will not be assigned to any other agent because nobody wins the vote. Then we have here where this is applicable. It is applicable in legal or industries or legal firm where evaluating ambiguous contract clauses. Three agents provide high confidence. So it is very, 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 very applicable in legal firm when you are designing agentic pattern, multi-agent system for legal industries. Then we have thresholds. Decision require configurable fraction, e.g. 67% majority of weighted votes. So make sure you set threshold if you are implementing this pattern. Set threshold of what the agent can have and threshold of voting, threshold of who can carry the vote and where the vote can reach before it's stopped. All right, guys. So agent makes decision by voting in democratic and peer-to-peer consensus, and they make decision by voting, consensus, and deliberation. No single agent has final authority. No, every agent has equal authority. All right, we move to the next one, which is 3.5, section 3.5, where we have manager worker orchestration model. So here, one manager agent assign work to worker agents. Okay, so worker agent receive, classify, check priority, select worker, track progress, and reassign process skill. So that is the work of manager worker agent. Its work is to basically check workers and assign tasks to workers while workers receive tasks. Then manager worker also classify tasks based on agents and the worker it has. It check priority of task and then select workers, okay, and track progress of the worker and reassign. If the particular worker agent cannot do the work, it reassign it to another worker agent. And then the process also allow queue. An agent can receive more than one task. So the task can use async or synchronous pattern. So asynchronous design pattern to keep messages in form of queue. So dynamic task assignment based on current load, capability, and specific task requirement. So this is very useful when you have dynamic task assignments as well. And then you have dynamic assignment. Number one, manager assess incoming work. Manager receive and assess incoming work and matches it to available worker versus fees tiers. It doesn't need assign it to available worker. It makes sure that the worker can handle the work. IT operations manager. This is also applicable in IT operations or IT incident management. So where the manager agent receive incident, assess severity, and assign the work to specialist worker. Maybe you have infrastructure monitor agent or you have application monitor agent. It's assigned based on the capability of the worker. Then worker status. So worker status allow the worker agent to track task, concurrency, and average completion time to manage load fractions. And then we have incident routing. So the manager worker agent also allowed incident routing by assigning how high priority incidents. So it assigns how high priority incidents to prioritize agent for immediate action or assignment, and it also allows queue preemption. Then we have resolution tracking. So it maintains visibility across active incident for SLA tracking and assignment. So it is very, very important where you have it is very, very useful in IT operations, particularly where you have agent that we perform infrastructure task, agent that will monitor or deploy application. You have agent that will observe metric and analyze metric in dashboard, and so on and so forth. So we move to section 6, 3.6, where we have pipeline and chain of responsibility pattern. So this borrows from the idea of data engineering design pattern, where we build workflows in form of and tie them together and orchestrate them via the ETL operation: extract, transform, and load. This also follow that principle of sequential execution, where one workflow does not start until the workflow before it is completed. So structuring workflow through sequential transformation or execution and evaluation separation. So this pattern is very, very important. It processes work in stages. Each stage has one responsibility. Okay, chain of responsibility is similar, and each stage decide whether to handle the input or pass it towards another. So it is very, very important. You have pipeline pattern where work is passes in sequential stages, either by classification, extraction, validation report with one responsibility. Then you have chain of responsibility. So each stage decide whether to handle input or pass to the next stage, ID for escalation workflow. And then we have actor-critic loop. So you have actor-critic in the system that will also separate execution from evaluation. So the actor proposes action while the critic evaluate whether the action is right or not. And then we have independent evaluation. So critique evaluate for compliance, risks, and policy of the system which has been designed and integrated into the system or into the workflow, and targets different from the actor's performance goal. Then we have refinement loop. So the orchestrator runs the loop. If a critique requires modification, the actor revises until approval is done. So this is very, very important in a sequential multi-agent design pattern in an enterprise. So this can be used for even designing data engineering agents, where you have operation as form of ETL or ELT design pattern. Then lastly, we have the last one, the eighth design pattern, which is hybrid orchestration before our summary. So hybrid orchestration allow the application of right coordination model to the right work for reliability and governable system. Okay, so it allows system to apply best pattern to each type of work. So there is no single design pattern, no whether the whole system should be centralized or the whole system should be decentralized, hierarchical, democratic, or pipeline. No, you can combine any design pattern together to work together. So this may actually increase architectural complexity, because if you are building procurement and you integrate centralized and decentralized at the same time, so how do you want to govern the system? So this is how you can design them when you are using hybrid. So in the multi-agent system, you can use centralized orchestration for procurement workflow And you can use decentralized or event-driven or distributed orchestration for supply chain and blockchain operation. And then you can use a manager worker, just as we have discussed, for IT incident workflow. You can use a pipeline plus democratic consensus for legal document intelligent operation. And then for vendor selection, you can use Actor-critic, that's under procurement as well. And then this is how you can combine them together. You choose a pattern for a particular business unit. Implement a pattern for finance, implement a pattern for procurement, implement a pattern for supply chain, implement another pattern for legal and IT operations. So this allow separation of concern and reduces complexity of the system. And then it enables you to also govern the system reliably without any bug. So we have discussed all these patterns, their use cases, primary value, and key trade-off. So let's run through them again. We have centralized. So the primary value of centralized pattern is it is governable and auditable. But the key trade-off is that there's no single point of failure. If the orchestrator fail, the whole system fail unless you implement temporal design pattern. Then we have decentralized system. So the primary value of this is that it is scalable because it is a distributed and event-driven system where agents communicate peer-to-peer by discovering each other and negotiating contract. Then the key trade-off here is that it is harder and it is harder to scale. Sorry, it is scalable, of course, but to optimize it is very hard. Then we have hierarchical agents. So where agents follow the operation of normal enterprise system in real life. So these align well with the organization or enterprise structure because it's built based on the hierarchy in the organization. But the creative trade-off here is that overhead at tier boundaries. So when in certain tier boundaries, there can be problem. So for if the CEO want to pass information uh, to the manager, for instance, he has to pass through all the stages before it gets to manager. And then hierarchical, the primary value is that it's aligned with the organization we just discussed that we have democratic. So confidence in ambiguity, that is the primary value. So it is very you don't have ambiguous assignment of tasks to a particular agent. Agent votes through consensus and gets tasks by weight or by votes that they won. The key trade-off here is that it is slower to time critical decision. So because agent can continue voting and time is going, you understand? So pipeline, so simple sequential flow. The primary value of this is that it is useful for simple sequential flow, like data engineering type of workflow, but it is limited to linear workflows. So this is only applicable for linear workflows. You cannot use it for any workflow that is non-linear or does not follow or a straight or sequential pattern. So this is what we have in chapter 3, guys. Please get the book for detailed information and code guide and full implementation. And then we have this architecture that we have put together. So choosing the right coordination model for enterprise AI. So the first layer is where you select inputs. So the input can be control needed, latency, auditability, workflow complexity. So you select the following inputs. You select this input based on this requirement. Do you want control? Do you want latency? Do you want the system to be auditable? Or do you want the system to be complex, the workflow to be complex? So based on that, you pass it to your orchestrator selector. This code is in the book for selecting orchestrator for your system. And then, so the orchestrator work through what it is passed and then select the right design pattern. You understand? If we have centralized. So we have the design pattern centralized, where one orchestrator coordinates all the agents. You can see the design pattern. One orchestrator coordinates several agents. Then we have two, peer-to-peer, or where, peer-to-peer, or democratic. This is where we discuss that agent votes. Okay, agent communicate directly with each other. Okay, so this is where we design, we talked about this is in step 2. The agent communicate directly with each other. And then we have hierarchical, where manager agent, like the CEO agent, and you have sub managers. You have that hierarchy design. And then you have worker agent as well, worker A, worker B, worker C. So manager agent delegates and oversees worker agents. Then we have the pipeline. This is sequential. If agent A is done, then agent B take over, then agent B continue, then agent 4 continue. So this is good in data engineering type of operation, where you have sequential execution: ingest, extract, analyze, and output. Okay, so ingest data, extract data, process the data, analyze the output based on KPI, and get visualization. So agent executes sequential stages in the fine flow. And then we have hybrid. So this is, using more than one pattern. So you have the orchestrator, we have specialist A, specialist B, specialist C, and you also have human in the loop for complex tasks. So orchestrator with specialist and human in the loop, that is hybrid. So best fit example, which one should you use for which workflow? So for regulated task, regulated workflow, better pattern choice. Okay, so best fit example. So which one should you use? If you have regulated workflow, you should use centralized. If you have flexible collaboration, you can use peer-to-peer. If you have task delegation, you can use the manager worker agent, which is hierarchical agent. If you have document processing, like in legal operation, you can use pipeline pattern. If you have enterprise mixed workload, you can use hybrid, where you also combine with human in the loop. So that is how it works. So this enable better pattern choice, safer autonomy, clear governance, and scalable coordination. So key insight from this chapter: the first insight is that no single pattern fits all. No, choose pattern based on the department or the problem you are trying to solve. The number 2, control versus flexibility. Determine if you want the agent to have full control, if you want the orchestrator to have full control, or you want agent to have flexibility. So determine what you want before you design. And the third insight is hybrid often win in enterprise. So in enterprise, you have, diverse departments that also interconnect. So hybrid workflow with human in the loop, we always win in enterprise system. So this is the end of chapter 3. Please get the book for more information for coding on how to choose the right pattern. Remember, all we discussed in this chapter are guide, design pattern, not full, workflow. We did not build full procurement agent, but we gave design pattern on how to build procurement agent, legal, supply chain, IT operation, and the like. So this chapter, as we have explained, is the design pattern guide for enterprise multi-agent orchestration. So see you in the next lesson, guys. Please like and subscribe so you can get more video from us. Thank you.